Hello and welcome to another WJEC A level physics question. This is unit 1 from January 2013 and it was question 1 on that paper. And the question is about a train basically going around a track where a complete lap of the track is 6 meters. The toy train takes 8 seconds to complete 1 lap, and then we're asked a few questions about the train and its motion, which is described by the distance time graph that's given. So first of all, we're asked to describe the motion of the train in the region from 1 second to 3 seconds. So 1 second is there, 3 seconds is here, and we can see in that region that the gradient of the line is decreasing, and the gradient of a distance time graph gives us the speed. So we're simply going to say that the speed is decreasing. We could say that the train is decelerating, and the reason we know is because the gradient is decreasing. On the next part of the question, we're asked to find mean speed of the train over the lap. So I'm going to use V bar to represent mean speed. Bars in physics represent means, and the formula for mean speed is total distance over total time. So the total distance was 6 meters given at the start of the question. The total time was 8 seconds, and 3/4 is 0.75 meters per second. On the next part of the question, we've got to determine the speed of the train at 6 seconds. Now, what I've seen some people do on this type of question is just to try to read the distance and the time off the graph. But when the graph is a curve, as it is in that part of the graph that we're looking at, the way to find the speed is a gradient. And we find the tangent, sorry, let's explain that slightly more clearly. We're going to draw a tangent at 6 seconds, and I've already done that on the diagram, and we're going to find the gradient of that tangent. So remember that the gradient of a line is the height of the line. So here we're looking at about 4.4 divided by the base. Well, the base here we're going from about 1.8 up to 8. So we've got a distance of 6.2 seconds. So 4.4 meters and 6.2 seconds. So the speed here would be 4.4 over 6.2. So I'll just put that into the calculator. And that gives us about 0.7 meters per second. I've got 0.71 on the calculator. Now, I wouldn't go any more than 2 significant figures with this sort of answer, because it's not easy to get a perfect tangent drawn, and you'll find that mark schemes for exams will give us sort of a reasonable range of acceptable answers. The next part continues basically testing our understanding of what the gradient of the line means. It tells us that the gradient of the graph is very large between 7 and 8 seconds, and explaining with reference to motion of the trains, explain whether or not it would be possible for the graph to be vertical. Well, remember that the gradient represents the speed, and a vertical line would have infinite gradient, which would mean infinite speed. So therefore that's not possible. Nothing can travel at an infinite amount of speed there. If the line is horizontal, well, the gradient there is 0. So that would mean that this thing is stopped, and so therefore this is possible. The final part of the question says that whilst playing with the train track, a physics student states, no matter how fast I make the train go, the mean velocity, and that's the key word here, over 1 complete lap is always going to be 0. We've got to explain whether or not that statement is correct. Well, mean velocity, well, velocity is a vector, so I'm going to give it an arrow over the top, is the total displacement, which is also a vector quantity, divided by time. And the total displacement for 1 lap is always 0, because we always end up back where we started. And therefore, the mean velocity is going to be 0 as well. So the student is correct. So the important point here was that we're talking about velocity, not speed, and it's displacement, not distance over time. And when we've completed 1 lap, we're back to where we started, so the total displacement is 0. Thank you for listening. Please remember to like and subscribe.